Hi and welcome to another very exciting tutorial. Today we are going to dive in right into Apple Watch development, and the demo application that we are going to create is pretty awesome since we are going to move forward from the last tutorial where we just saved a location. Today we are going to use the Apple Watch to save our current location. So this is going to be our demo application on the iPhone. You can see that I'm currently in Manhattan, and once I click plus or press the plus button, I can actually add my location. But let's do that on the Apple Watch now. So here's my Apple Watch, and I'm going to press on the WristyLocation icon, and as you can see, there's just one single button. And if you observe now, once I press that button, we're going to push to a new view controller, or interface controller as it's called on the WatchKit SDK. And here you can see that we're currently in Manhattan, and also you can see that this location has immediately been transferred to the iPhone. So this is going to be really exciting since we're going to use different technologies like CoreData. We're going to use the WatchKit SDK. We're going to talk to the CoreData database using App Groups so that we can share the information between the WatchKit extension and the iPhone app. And you're going to learn how to set up the WatchKit extension and how to manage to transfer data from the iPhone to the Apple Watch. But before we get started, I'd like to introduce you to a new learning service that I've been working on for the last couple of months. It is called PRENTIS and is all about bringing people together who want to learn. PRENTIS is actually a place or a platform where you can offer your talents, or where you can find talented people who want to offer their skill set to enhance yours or to offer you assistance with your current projects. This we try to offer it on a two-pillar basis so that you can actually use it if you're a student at school or if you're a university student, to offer tutoring offers for students so that you can help them improve their skills in a specific subject, or that you can get help from people directly in your area. As you can see, what we have tried to do is bringing you a very easy way to find people nearby. We call this the distance line, and as you can see, we're in this example, we are located in Berlin, and there are 15 offers in our vicinity or in our area, and these people here are offering different kinds of skill sets, like Lisa Bauer here, she is offering app design basics, or Paul Friedrich, she is offering mathematics and physics school training. So let me just give you a little demo of what PRENTIS looks like in real life. So this is live from my iPhone now, and as you can see now, we are located in New York, and there is one offer in my area, and there is this Nick Holden, which offers a one-to-one training regarding photography. So once I press on Nick, you can see what he offers. He offers photography and has a little description here. You can see how far he is away, so he's pretty close in my example now, and he wants us to pay $24 per hour for his service. So if I want to get in touch with Nick, I can just start texting, and I've already contacted Nick and said, "Hi, how is it going?" And then Nick can respond, and we can figure out the details of our agreement. And this is actually a pretty easy way to get in touch with people close to you who can offer you different kinds of skills. And also, if you want to create an offer and share your talents, it's pretty easy since you can just select the type of offer you'd like. If you want to offer tutoring for students, or if you want to offer one-to-one training, as you can see, a one-to-one training, and there is Nick Holden responding to me in that case, says, "Hi, Brian." And as you can see, this is a pretty easy way to get in touch with different people. And if you want to create an offer, you can simply choose a profile picture and give your offer a title and describe shortly what students can learn. And it is the same thing is true if you want to create an offer for school tutoring. The only difference is that you have to select the subjects that you would like to teach, and of course you can select the the price that you want people to pay for your service. And here, since Nick just got back to me, you can see that there's this red icon on chats, and then you can go back to your chats and just continue your communication with Nick in that instance. So this is what PRENTIS is about, and you can download it for free. The whole service is free on the App Store. I'd appreciate your feedback on this, and if you'd like to see more features and or different kinds of features, and also let me know if you find that service useful. So after that, let's move forward and continue with our new Apple Watch application, which we are going to call WristyLocation. So let's fire up Xcode and create a new project, which is a single view application. We're going to call it WristyLocation. And in that case, make sure that you have selected as a device the iPhone, and make sure that you have set this check mark so that we can use CoreData in our application. Click Next and Create, and there we go. Doing this little setup will create a WristyLocation CoreData data model for us, and also will add some code to app delegate, which we're not going to use, but anyways, it's useful. And to get started, we are going to select our main storyboard file, and there is our view controller, nice and clean, which we are going to embed into a navigation controller actually, so that we get a nice navigation bar at the top of our application. So just select this view controller icon here at the top, click on editor, and embed in navigation controller. And there we go. That's it actually. We have our view controller and our navigation controller now in our storyboard. And the first user interface component that we want to add is a MK map view. So I'm just searching for it here in the, how is it called, object library, and we will bring it up and just put it in a way that it is at the top. In that way, we will get a nice blurry effect beneath this, so that this map view is a layer under the navigation bar, and this is quite a nice effect actually. So this is the first user interface component that we are going to use, and the second is a simple table view. So I'm simply adding the table view here, just beneath the map view, and resize it in a way so that it fits to the storyboard. And what we want to do next is actually adding some constraints. So what I do is pressing Control on my keyboard, click on the map view, and drag to the containing view, to the view that is the basic view of the view controller. And I'm going to select leading space, I'm going to select trailing space, the top space, and press enter. And what I also want to do, I want to fix this map view in height, so I simply press Control and drag this in this way within the MK map view and select the height. And now, as you can see, we have only blue lines, which means that we have now all constraints set properly. But when I think about it, maybe I want it a little bigger, the map view, something like this, and this a little higher now. All right, and as you can see now, we now have some orange lines, but that's no problem. We can simply click on this yellow arrow here in the document outliner and select this exclamation mark here and say update constraints and fix misplacement, and that's it, and we are blue again. And what we want to do next actually is adding some constraints for the table view. So first of all, we want to add vertical spacing between the table view and the map view, and what we also want to do is adding some constraints to the table view regarding the leading space, the trailing space, and the bottom space, and hit enter. And that's it. Now we have actually our user interface almost ready. What we also want to do is add some bar button items on the left side and on the right side of our navigation bar. One button is going to be a reload button or a refresh button, which will refresh our location, and the other one is to add a new location to our database. So let's start with this one. I'm going to go to the attributes inspector here, and as an identifier I will simply say add, which will give us a plus icon here, and in that case of the left button I will say, let's see, reply, no, refresh. Let's use refresh, which will give us this circular arrow. So this was the first part actually. Now as you can see, our table view is pretty empty, so what we also need to do is add a table view cell, a prototype cell, which we're going to simply add here, and this will give us the opportunity to use it just if we would work with a simple table view controller instead of a table view user interface object. And let's also give this cell a identifier in the attributes inspector, which is simply going to be cell. So this is actually our very simple user interface for the iPhone app. So what we need to do now is add some outlets. So let's bring up the assistant editor and let's create an outlet for our map view, which is going to be, we're going to call it map view. And also let's create an outlet for our table view. I'm just using my document outliner here, and let's call this location table view and enter. And let's also add some actions for the buttons that we are going to use, which is going to be in this case add location. Let me just zoom in a little, which is going to be an action and connect. And let's do the same thing for our refresh button, and let's just call this action refresh location. All right, here we go. And as you can see, we still have an error here which says that we're using an undeclared type MK map view. So in order to get rid of this error, we will simply have to import the map kit to this view controller, and as you can see, the error disappears. And we will need to import one other library here, which is going to be CoreLocation, so that we can use the CoreLocation classes. And the first class that we are going to use as a property here in our view controller, so let's close the assistant editor and open the standard view controller Swift file. So what we want to do next is creating a location manager. So let's add this property, location manager, which is going to be a CL location manager. So the CL stands for CoreLocation, and we will initialize this location manager directly in view did load. So every time our app gets started and the view loads, for the first time, we're going to initialize our location manager with the location manager instance. And we will also have to set a delegate for our location manager. So let's say the delegate is equal to self. And that means that we will also need the CL location manager delegate for that to work. And since we're just dealing with some delegates, we also need to implement the UI table view delegate and also the UI table view data source for our table view to work. And since we're now dealing with that stuff, let's also create a function for the table view setup. We will call it setup table view. And we will call this function directly under the location manager initialization. So let's call setup table view. And what we do here in setup table view is pretty basic stuff. So we will use our location table view and set its delegate to self. And also we will set the data source to self. And as you can see, we get some errors here because we have not implemented all the delegate methods that we are going to need. So let's do that in the next step. So for the location manager, we are going to need two delegate methods. This is going to be the location manager did change authorization status, and also what we are going to use is location manager did update locations. This is these are the two location manager delegate methods that we are going to use. You could also implement a delegate method that will allow you to check for errors when the location gathering process is not working. But let's now continue with the table view delegate and data source. Let's maybe add them at the top here, which is going to be a number of sections in table view, and we will simply have one section, so we return 1. And what we also are going to need is table view number of rows. So number of rows in section, and let's simply return 1 here at the moment, since we have no data model at the moment which we can use. And now we can simply build our application. And as you can see, we still have no data source here, and what's missing is the table view cell for row at index path method that we really need. So now that we have the standard table view controller or table view method cell for row at index path, let's also create a table view, a dequeuable and reusable table view cell. So let's add a constant and call it cell, and we will simply use the table view parameter here and call the dequeue reusable cell with identifier for index path. And we have given our cell the identifier cell, and we also have the index path as a parameter here, and all we need to do now is cast that to a UI table view cell. And that's it. Actually, now we have a table view cell up and running, and if we now say cell.textLabel.text equals hello world, and now in addition return the cell, then we can actually give our application a little try in the simulator. And here we go, we have our map, we have our table view with the one row that we have allowed to be displayed. And with that basic setup up and running, we can move on to our data model. And if you're not familiar with CoreData, there are some pretty interesting CoreData videos on my channel somewhere last year, and there you can get the basics of CoreData. They are also still valid for Xcode in version 6. And how we are going to deal with it in Swift, you're going to see in a second. So to get started, we have selected our data model here in our project, and what we want to do first is to create one entity, and that is actually all we need to do. And to do that, we will simply have to click on this plus icon here at the bottom of the screen, and then we will get one entity here in the entity list. And by clicking on it, we can change the name, and we will simply name it location. And we're going to need 2 attributes for our entity location. The first one is going to be a title for the location, which is going to be a string, and the second one are the coordinates that we want to save as a binary data, since we are going to archive that as binary and as data objects. So now that we have our entity set up and we don't have to create any relationships here, we can move on and actually create the managed object classes, and simply by clicking on editor and create an as managed object subclass. And by doing so, we get this this little pop-up here where we have to select WristyLocation and select that, click next, and again here we have our entity location. And we will use Objective-C in our case here, and we will also add our targets to WristyLocation, and we will not use scalar properties for primitive data types. So actually this is standard, all the standard configurations, and we'll hit create. And since we're going to use the Objective-C version of this NS-managed object subclass, we will have to create a bridging header, which Xcode asks for right here, and we will say yes, so that it creates a bridging header for us. And there is our class location, the header file, and the implementation file, and there is our bridging header. And to use this managed object subclass, all we need to do is actually write an import statement and call it location.h. And now there is a question for map from a firewall, but that's okay. So now that we have this this managed subclass up and running, what we can do now is make our lives a little easier and create a CoreData helper class, which we will use to get access to CoreData. Although we have a CoreData stack already created for us in App Delegate, what we want to do is we will simply get rid of that CoreData stack in App Delegate because we will not need it. And we will create our own class, so we will simply remove everything here. So what I removed is actually all that is in the App Delegate file from the mark CoreData stack to the bottom, and also this call self.save context. We won't need that. This just makes our App Delegate file a little more easy to read. And what we want to do now is actually press Command N on the keyboard and create a new Cocoa Touch class. And we're going to call this class a Swift CoreData Helper. And this is going to be a subclass of NS object. And the language is going to be Swift, and we hit Next and Create. And this is going to be a really useful class, so you can actually use that in many cases every time actually you're going to use CoreData. And we're also going to talk about the requirements for using CoreData in relation when we are dealing with WatchKit apps, since we have to talk about the so-called app groups in a second. So before we do that, let's also import CoreData to this file so that we can use all the CoreData classes. And as you can see, we have now our CoreData class, Swift CoreData Helper class here, and it is a subclass of NS object. And the first method that we want to define is actually everything is going to be we are going to use class methods here, or class functions, so that we won't have to create a real object of this class. So we will simply write class function, and the first thing we need to do actually is create a managed object model, which is going to return a NS managed object model. And the first thing we are going to do is we will define a so-called proxy bundle. And this is going to be the proxy bundle. And this is going to be the NS bundle. So this is something we have to create. And what you need to do here is give this an identifier. And we can actually you can use your reversed URL for your project. So I have ComTraining WristyLocation here. So I'm going to use the ComTraining identifier, followed by the watch proxy that we are going to create in a second. So this is the first part. The watch proxy is going to be a new target that we are going to add to our project in order to use it as the connection between our iPhone application and the WatchKit extension. And the next part is going to be that we will create a model URL, which is going to be the proxy bundle and its URL for resource, and we will use the name with an extension. And what we have to add here is actually the WristyLocation data model. So this is going to be WristyLocation WristyLocation, and the file extension of a data model is MOMD. This is the managed object model. So this is something we need to unwrap. And now we can actually simply return an NS managed object model with contents of URL, which is the model URL. So what we need to do in a second is, first of all, we need to unwrap this as well. And what we need to do then in a second is actually create this watch proxy target in our application, and also add our WristyLocation managed object model to this new target. And what's the problem here? Well, we need to unwrap this here as well. So this should do it. So have a look at this line again. You have to unwrap the model URL here, and then again the whole NS managed object model object. So now that we have our managed object model, what we need to do is define another class function. And again, a class function is always used when we don't want to create a instance of a specific class in order to use this method. So this time we're going to create a method that is called persistent store coordinator, and in this case we are going to return NS persistent store coordinator. So what we are basically doing right now is creating a core data stack, if you haven't noticed yet. So, and in this case, this NS persistent store coordinator is optional, and we will define an error variable here, which is going to be an NS error, and an error object always needs to be optional, since it needs the possibility to be nil, because if there is no error, then this object will be nil. And then what we need to do is create a so-called shared container URL, which is going to be an NS URL, and also is going to be optional. And what we need to do here is we need the NS file manager and the default manager, and we will then ask for the container URL for security application group identifier. And this now is the fun part, actually, where we'll talk about the app group that we need to define. So let me first of all leave this empty, and what we want to do now is maybe go to the top of our Swift Core Data Helper and add another class function, which we will call shared app group. And what we want to return is just a string, and this string is going to be always it's always going to start with group. And I'm going to continue with com.training.WristyLocation, because this is our identifier for our shared app group. And now let's have a closer look at these shared app groups after we have gone to our container URL for security application group identifier, and we will simply now call this shared app group class function. And since we don't need to create an instance of this class Swift Core Data Helper, what we need to do is actually type in the class name, which is Swift Core Data Helper, and then ask for the shared app group, which will then return this string. And now let's have a look, before we continue and move on, what shared app groups really are. So let's have a look at the documentation here, and I've just opened the app extension programming guide, and here are the sharing data with your containing app. So when we have a look at this figure here, then you can see that we have a containing app bundle, and within this bundle we are going to add, this is actually our application as it is in the moment. We have our bundle here, where our for example our storyboard is included, and so on, or our data model And when we have a look at that, you can see that there's also going to be an extension bundle, and this is where our WatchKit application will actually be. There is going to be a so-called WatchKit app and the WatchKit extension, and the extension is what runs on the iPhone, and the WatchKit app is what runs on the Apple Watch. And the extension needs to communicate with the actual iPhone application, and this is going to happen by using this optional shared container. So the extension has a container, the app has a container, and the app has a process, and the extension has a process, both running on the iPhone. And what we need to define is a so-called shared container, or a app group that we are going to use for this shared container. And to create such an app group, you're going to need to do some pretty interesting steps. So let's actually have a look, and let me just bring up this slideshow. So first of all, what you need to do, or what you need to have, is actually access to the Developer Center. So you can actually only continue if you are a registered Apple developer. And once you have opened the Developer Center and went to the certificates, identifiers, and profiles, what you need to do is create an application ID. So in this case, we have WristyLocation, and I have my bundle ID. And what you need to do then actually is to specifically activate the so-called app groups as a service. So you need to enable these app groups for this specific app ID. So once you have completed that step, you need to move forward, and under the identifiers header here, you need to select the app groups, and then you get a list of your application IDs, and then you will have to add an app group. So you will get a plus here, and then you can actually add this this app group, and then you want to give that a name, and it always has to start with group. The identifier always has to start with group, and you can give it a description, but the important stuff is actually this part here. So in our case, group.com.training.WristyLocation. So you have to use your unique identifier in that place. So then we continue. Then we need to go back to the app identifier, to the app IDs, and go to our WristyLocation app ID, and then you can see that the app group is actually be configurable. And what you need to do then is actually edit the whole app ID, and once you did that, you can select an app group for this specific app ID. So once you did that, you click on the check mark and hit continue, and then we are going to need to go back to Xcode. So you open up your project again, you click on the project and click on capabilities, and then you will need to add the capability of app groups. And this is something you need to do in both targets, the WristyLocation iPhone application, which is this one, and also within the WristyLocation WatchKit extension, which gets this E at the start of the entry. So this is what we need, what you need to do now in order to continue before we can continue with our Swift Core Data Helper class, actually. And then you need to activate, of course, this group that you just created. And if something is red here and something doesn't work, then you need to check, and this is really important, you need to check your developer and also your production certificates that you can generate in the Developer Center, and maybe you need to revoke and request new ones in order for this to work. So actually that's it, and you can maybe you need to go through this again, but these steps that I just demonstrated to you are really necessary in order for this to work. So maybe you pause the video now and continue once you did that, and then we will focus again on the Swift Core Data Helper. Now that you're back from your vacation to the Dev Center, it will get clear why you have called this shared app group with group.com.training, or in your case, your reverse domain, But this should be clear now why you use this string here and why we also used it here within the for the container URL for security application group identifier. So now that this is done, what we need to do after we have our shared container URL is we need to check if the shared container URL really exists. So we will say shared container URL equals the shared container URL. And if it exists, then we can now use the value, since it was optional, we can now say let store URL and use the shared container URL, and then ask for the URL by appending path component, and then give our database a name, and we'll simply call it database.sqlite. So after we have our store URL, what we also need is going to be a coordinator. So this is going to be a variable, a coordinator, and this is going to be our NS persistent store coordinator, which is also going to be optional. So now we use the NS persistent store coordinator and initialize it with a managed model. And to do that, we will simply call for our Swift core data helper, and we already have our function that will return the managed object model and ask for it by calling this class function. And again, since we are using class functions, we don't need to create an instance or an object of our class Swift core data helper. And now that we have our coordinator, we can use it to add a persistent store, which is actually all we need to do in our function here. So we use our coordinator. We use the coordinator and add the persistent store with type, and we are going to unwrap this, so we don't use an exclamation mark, we don't use a question mark, we use an exclamation mark, and the store type is going to be NSSQLite store type. We won't need a configuration, and our URL is already known. This is going to be the store URL. We won't need any options, and there we can pass through our error variable that we have already created. And then in this, actually you could also create an if statement here that would allow you to track the error. So you can use the error here to give yourself more information. We'll skip that for now, and we will now return our coordinator here. And since we also have the possibility that this fails, so that we don't actually have a shared container URL, if we can't find a shared container URL, then we will return nil at this position here, and our build succeeded. Now we have a managed object model, we have a persistent store coordinator. Now all that is missing for a complete core data stack is actually a managed object context. So let's also add the managed object context as a class function, and here we will return a non-optional NS managed object context. And to return this managed object context, we'll create a constant for our coordinator, and then call our coordinator by simply saying Swift core data helper and persistent store coordinator. And then what we can do is we can create a managed object context variable and call NS managed object context and initialize it with a concurrency type with a concurrency type, and this is going to be NS managed object context concurrency type dot main queue concurrency type. So this means that our managed object context is always associated with the main thread or the main queue in our application. So now what we need to do is actually change our managed object context and and change the persistent store coordinator property, and there we will simply set it to our coordinator, and then we can return our managed object context. And we will use this class function here quite frequently, and now we will add some convenience methods that will help us and make our lives a lot easier when we work with the work with core data. So first of all, let me just define those function headers. These are going to be class functions as well. First of all, we'll say insert managed object. This is going to get a class name, which is an NS string. Then we will need an NS managed object context. So let's call it managed object context. This is going to be an NS managed object context. And then what we will return is going to be any object. So this will give us an error until we have actually returned an object. And then what we also want to do is we want to be able to save our managed object context. So we'll say save managed object context. Let's give me some space here. All right. So now we want to save our managed object context, and what we need in order to do that is a managed object context as a parameter. So NS managed object context is going to be the type of it, and we will simply return a bool so that we can check if there was an error during the saving process. And the last method that we want to define is also a class method, and we will call this fetch entities, and this will help us to get entries from our database. And again, we will need a class name in both cases. For the insert managed object and for the fetch entities, we need class names in order to get the NS managed object subclass to work with core data. So again, we will use an NS string, and we will allow it to use predicates. So with a predicate, which we'll call predicate, and this is going to be optional, so we add a question mark. We won't need this in every call of our method, and we will also add a last. We will actually add two more parameters. The last one is going to be a sort descriptor. We won't need that for this tutorial, but you will find it quite useful to work with sort descriptors. So we will include them here in this class so that you can use it in your project. So this is going to be a sort descriptor, and this is an NS sort descriptor, also optional. And what we actually really need is a managed object context. So this is going to be an NS managed object context. And actually that should do it. And what we want to return is in our case, it's easier to work with an NS array. So after this huge method definition, we can actually add our curly braces and start implementing these functions. And let's start with the fetch entity. So what we need to do first is create a so-called fetch request for the database. So fetch request, which is going to be an NS fetched request, NS fetch, come on, fetch request. There we go. And now what we also need is a so-called entity description, which is going to be an NS entity description. And then we call entity for name. And now we actually use our class name and cast it to a string. in the managed object context. So actually this is the most important thing here, that we have an entity description, and we will get this entity description using this class name here as a string. And the nice thing is that we can always use the NSString from class method to make no spelling mistakes. When you work with more NS managed object subclasses, this will come in quite handy. So this is the first step, the fetch request and the entity description. Now that we have that, we can use the fetch request and set and give it the entity, and we're using the entity description here. And if the predicate, that is actually optional, is not equal to nil, we will also supply our fetch request with the predicate. So it's going to be predicate. And we will do the same thing for the sort descriptor. And this is not equal to nil, then we will also supply our fetch request with the sort descriptor. And as you can see, we are asked for this is a plural, so sort descriptors. So what we need to do actually is unwrap the sort descriptor and place it within brackets so that we can indicate that this is an array. And also we will unwrap the predicate here. So because we already know that it is not nil, that means we can unwrap it and supply the fetch request with the proper information here, the predicate, and here the array of sort descriptors, which is only one in that case. So now what we also need to do is set the returns objects as false to false, so that we get full objects that are not somewhere hidden. This will make it easier for you to access the information that is going to be retrieved from the CoreData database. And now all we need to do is to create an array of items that we can return. So we will use our managed object context and execute a fetch request, which uses the fetch request we defined, and we won't need an arrow here, and then we can simply return the items as we have already stated here when we entered the return type of NSArray. This is giving us an array of any objects, but this works quite nicely. So now that we have created this fetch entities function, let's continue, let's say, with the save managed object context. This is quite simple. So we will simply say if managed object context dot save. We want to use an array here. So if this was successful, we will return true, and else we will return false. So that is that. And now let's head to the last class function here, which is going to be the insert managed object function. And there we will create a managed object constant by using the NSEntity description and say insert new object for name. Again, we're using the class name as a string. In our managed object context, and this was actually the first step, and we still have to cast that to an NS managed object, and then we can actually already return the managed object. All right, so now we can build this, and hopefully we did everything right. And then you have a Swift CoreData helper class that allows you to work with CoreData pretty easy. And we have already made all the adjustments needed in order to work, in order for this to work with the app groups, so that we can use the CoreData database on both the iPhone and the Apple Watch application. Now that we've finished our Swift CoreData helper, we can head back to our view controller and create a managed object context property. at the top of our class. So let's create a managed object context, which will abbreviate with MOC, which is a managed object context, and then we will use the view.load method to initialize it, and now we can simply use Swift CoreData helper.managed object context to give us our unique managed object context, which we will use while the app runs. And also we will use this managed object context later in the WatchKit application. Now, in order for us to get the data that we need from the database, we need to save it somewhere. So what we will also do is we will create an array of locations, which we'll call location array. And this will be an array of location objects. So we will initialize this directly here as a property. And what we also will need is a current location object, which will be a call location. So far, so good. Now let's talk about the way we load data. Actually, we will create a separate function for that. So let's say beneath the setup table view, we will create a load data method. And this will clear, first of all, the location array. So every time we reload, we will have a clean location array, location, and reinitialize it. And to get all the data from the database, we will say location array dot equals Swift CoreData helper. And now we can use the fetch entities function that we have just written to our Swift CoreData helper class. And now to get the class name, we can use NSString from class. And now we can simply enter our class here, which is location. We won't have a predicate, and we won't have a sort descriptor here. And the managed object that we are going to use is MOC, the managed object context that we have already defined. And what we need to do now is to cast that to a array of locations. So we'll simply say as location array, and that's it. And now that we have all the data we need, we can call our location table view and tell it to reload its data. So this is actually our data model. And now that we have called reload data, we can also use the location array to define the number of rows that we want to display. So we can now use location array dot count to get the real number of entries that we want to display. And because we are at the moment working with this data from our database, let's also have a look at the cell for row at index path method. And all we need to do here is, after we have defined the cell, we can create a location object and then use our location array to get the proper location object for this cell, and we will simply use indexPath.row to access the proper location object. And instead of hello world, we can now use our location object and access its title, since this is an attribute of our entity location. And using the NSManaged object subclass enables us to access those attributes directly via a property of our location object. And that's it, actually. But now that we are able to retrieve data from the database, we should also think about the ways we can actually put some data there. We have already added the delegate methods of the location manager, but as you can see here, the did update locations method is actually not the one I really wanted. It is the method we want is did update to location. So this is a little easier to handle. And what we want to do in did update to location is we want to set the current location property that we've already created to the new location, and if the new location and its distance from location, and we have an old location as a parameter here, is greater than 500 meters, then we want to display our location again. So this is a function that we have to still have to write. And what we also need to think about is what if the application was loaded for the first time. Then we also need we also need to update our location and display this new location. So let's call this property first load, and we also need to define that, and again display our location again, and then we will set first load to false. And let's first of all create the function display location, and then let's add the properties that we've just talked about, and this is first load, and we'll set this to true, and the other one is yeah, that's it. We only have the property first load, and we have not first load, it's first load, and we have the display location function. All right, let's build that. Should work. Where is... There is no error. Let's see. I don't know why, but I have maybe added a mistake to the Swift CoreData helper. There was a Y too much, but well, it's gone now. Let's go back to Swift, to our view controller, and build again. Well, and the build succeeded. Now, this approach by only updating the location after we have moved 500 meters enables us to save some resources on the iPhone. And now let's talk about the way we can actually display our location on the map. And this is actually pretty straightforward. We simply check if the current location object is not equal to nil. So if there is a current location available, we use our map view and set its region to a MK coordinate, region make, and the center of the coordinate is a CL location coordinate 2D, and we will use the 2D make method here, and the latitude is actually the current location dot coordinate dot latitude, and the same thing applies to the longitude, current location coordinate longitude. And to define a span for our map view, we'll use MK coordinate span make, and we will use the latitude and longitude delta of 0.05 and 0.05, and it should be animated. And that is actually all we need to do to display the location. And to be actually able to retrieve the information we want to get our location, we need to do an additional step. So let's head back to view.load. And before we actually set up our table view or do anything else, so actually let's say after we have created our managed object context, we should check if the user has allowed our application to use the iPhone's location. So let's create a constant for the CL location manager's authorization status. So let's ask it for the authorization status, and by checking this code with an if statement, we can see if the CL authorization status is not determined, And if this is the case, if it's not determined, so if the user hasn't decided yet, we will check if in our bundle, NS bundle, and the main bundle, and in the object for info dictionary, we have the NS location always usage description. So if we have that, and we should actually get this, if we have set this key, which we will do in a second in the info plist, then the user has to allow our application to always use location services even if the application is not turned on. And we need that authorization, because if you don't allow always usage, then we can't get the position of the user using his or her Apple Watch. So if this is not equal to nil, so if we have set this key in our info plist, we use the location manager to request always authorization. So, and then what we also can do is we use else if, and if the code is equal to seal authorization status denied, or code is equal to seal authorization status restricted, then you would have to present the user with an alert view that says, for example, can't use app, because this is all about using using the user's location. It doesn't make sense to do anything else if we can't use the user's location. So if the authorization status is not determined, we will request authorization for our application. But if it is already determined and we can use the user's location, then what we can do is ask our location manager to start updating the location. And then we can set up our table view. And while we are here, let's also call the load data function in the setup table view function. And head then back down to the location manager, did change authorization status. And now that we have requested the authorization status, it is necessary to think about the way the things continue after the user has opened the application for the first time. He decided to allow us to use his or her location. Then we need to check if the status is unequal to seal authorization status dot restricted, or the status is unequal to seal authorization status denied. So if this is the case, what we can do is display the location. All right, now I've already told you that we need to change the, or to add a specific key, the NS location always usage description key, to the info plist. So what we need to do is open the supporting files in our project, and also open the info plist. And what we need to do now is add this key. So we say add row, and what we want to do is here add this NS location always usage description, and this is going to get a value, and we will simply say location is required dot dot dot. So you can actually fill in the blanks here and simply decide what you want to write in this case. Now the only thing left to do within our iPhone application is to be able to add a location using the plus icon that we have added to the navigation bar. So we already have this function in place. It is called add location, and now we'll fill in the necessary code here, and we will simply use a alert view here. So add location alert is going to be a UI alert controller, initialize it with a title, which is where are you. We'll have a message which says enter a location title. We will have a preferred style, which is alert, and then we will add a text field to our add location alert, which is add text field with configuration handler, and we don't really need a handler, so this is going to be nil. And then we will add two actions, which is add location alert and add action. This is not going to be a UI alert action with a title that we're going to call cancel, style is cancel, and the handler is going to be nil. And the second one is add location alert, add action, and this is the fun part of this alert action. The title is going to be add. The alert action style is default, and the handler will get an alert action. And now we can actually start with coding here. So the first thing we need is the text field that we've already added. So we use the add location alert, get the text fields, get the first object from this array, and cast this to a UI text field. Since we know that we only have one text field, we can use the first method here to get really only the one that is inserted into this text fields array. And the next step is to check if this text field really contains text. So if it's not equal to an empty string, what we can do now is the core data stuff that we have all been waiting for. So now we can create a location object, and we're going to use the Swift core data helper and insert a managed object of class. So we again will use NS string from class location to get the name of our NS managed object. In our managed object context self.moc, I have to use the self keyword because I am within a closure at the moment, and we will then cast that to a location object. And now that we have created a location object, we can use it and manipulate its properties, which is first of all the title, which we will set to the text field's text property. And then what we also need to do is create a location itself, so that we actually can save some coordinates into our location object. And to do that, we will create a CL location object and initialize it with latitude and longitude. And we get this latitude and longitude from our self.currentLocation .coordinate.latitude property. And again, for the longitude, we again use the current location property and its coordinates and its longitude. So now that we have created our CL location object, we can also use the location database object, location object, and its coordinates. But remember, we have defined it as binary data, so we have to supply it with an NSData object. And the simplest way to do that is to use the so-called NSKeyed archiver. Keyed archiver and archive data with root object. So, and now all we need to do is add the location here. And of course, later we can again unarchive this data. So now, after we have created our object, all we need to do is again use our Swift core data helper and save our managed object context and supply it with the parameter it requires, which is our current managed object context. And after we have added an object to the database, what we need to do is, and after we have saved it, we need to reload our table view using the load data function. And so that all of that happens, what we also need to do is say self present view controller and location alert. We want it to be animated, and we don't need anything else here. To complete our work on the iPhone app, we need to do three more things. First of all, we have still an unimplemented method here with it, which is the refresh location. And all we need to do here is actually call our location manager and start updating location again, and afterwards display our location. Then once we actually click on or press the on a table view cell, we should also be able to do something. So the location that we have saved should be displaced on the map. So let's go a little up to the self row at index path and also add the table view did select row at index path method, and to realize to make this happen so that the map is updated, what we need to do is create again a location object based on our location array and using the index path dot row to get the proper location object. And all we need to do now is create the coordinates, which we'll simply get by using the NSKeyed unarchiver. Since we've just archived them, we can now unarchive the data using the location object and its coordinates and cast that to a CL location object. And now we can again call our display location function, and now it would be nice if we could simply pass our coordinates to this function. So let's do that. On the coordinates, I will just copy that. And this makes us realize, since there is no function display location that can receive a parameter, we will simply have to update our existing display location method to work this way. And to do that, we will simply, first of all, copy our location, display location function, and add a parameter, which is of course a location of type CL location. And actually we can also remove the stuff that is inserted here. So what we need to do is call our map view, set its region again, or let's keep that. That's nice. So I've just undone this because we need to do the same thing here, set the region. And instead of using the current location, we will use the parameter that we just received. So I just copied and pasted it to our call here. And now we also want to set a pin on that location. So let's create a location pin, make a CL location coordinate 2D object with a latitude and longitude, and we use the location and its coordinate and its latitude, and the location, its coordinate and its longitude. And now we can create a so-called annotation for our map, which is an MK point annotation in our case. And now we can say annotation dot coordinate is going to be our location pin. And the last thing we now need to do is tell our map view to add an annotation, which is our annotation. And then after we have added it, we also have to show it. So map view show annotations, and then we will have to supply a array of annotations. Since we only have one, this is only the one we have, and we'll set this to true so that it is going to be animated. And that actually completes our work on the iPhone application. And this is now a pretty good starting point to begin thinking about everything we need to do with the Apple Watch. So as I've told you earlier, we're going to use app groups to share the data. We have already created a Swift CoreData helper file and the Swift class, which will allow us to save data and retrieving it wherever it is, whether it's saved by the WatchKit extension or by our iOS application. But now let's also really add a WatchKit application or a WatchKit extension to our application. We're going to do that by hitting File, New Target, and selecting Apple Watch and WatchKit app, and click Next. And what we are going to do is simply leave out the notification scene. We don't want a glance. We simply want our notification We simply want our application to have a Apple Watch extension and Apple Watch WatchKit app. So hit finish, and it asks us if we want to activate WristyLocation WatchKit app scheme. So we will activate it. So this was the first thing, and as you can see, we now have 2 more folders here, which is the WristyLocation WatchKit extension and the WatchKit app. So let me bring up the bridging header to this folder here, so that we don't have a mess around here. And what we now also need to do is select our project again and create another target, which is going to be a Cocoa Touch framework, which we will call Watch Proxy. All right, so we will call this Watch Proxy and save finish. And this Watch Proxy now will allow us to give the necessary classes and the necessary files access from both sides. So from as well as from the WatchKit extension as the iPhone application. And one of those files is the Swift CoreData helper. And what we need to do is actually clicking on the Swift CoreData helper and select the file inspector, and now we have to add target memberships, which is going to be the WatchKit app, the WatchKit extension, as well as the Watch Proxy. And what we also will need to do is selecting the data model, which will also need to be only in the Watch Proxy, and we also need to define the location and as managed object to be only part, so as well the header file as the implementation file need to be part of Watch Proxy. After you have made those adjustments, you have to make sure that again you have activated the capability under the capabilities tab in your project settings, the app groups. So you have to turn them on in both targets, your iOS application and also in your WristyLocation WatchKit extension. This is pretty important. If you don't activate and select the proper app group in that case, then you can't share data between the Apple Watch app and the iOS app. So to get started with our Apple Watch app, we simply have to open our WatchKit app here and open the interface storyboard. And as you can see here, it is it just looks like a normal storyboard with a view controller in it, except that it's much smaller. And we when we start our application, we simply want to add a button here. So I place it there. I will call it Save Location. And the nice thing about those interface controllers of the WatchKit SDK is that you can pretty easily adjust positions without using any constraints. So if I go into the attributes inspector and have the button selected, I can say that it should be centered vertically in my container. So now it's pretty nice interface, nice and clean. And to continue, we will now add another interface controller. So this is actually the same thing as a view controller. So we can also create segues between them. So if I want to click on the save location button, then I can click drag to this new interface and say push, and then we are actually pushing to this new interface controller. And the interface controller will be the home of a simple map. So there's our map, there it goes, and a simple button which says done. And there we go. And to test that, we can even use a simulator for that. We will run our WristyLocation app in the simulator. It works nicely. We are being asked if we want to allow our application to use our locations. we see the description that we have entered in the info plist. I'm going to allow that. And now we can actually change our target here by clicking on our WristyLocation application and change it to the WatchKit app. And now make sure that you have selected a simulator and open hardware and external displays. And now we can actually even select the type of Apple Watch that we want to test. So I'm going to select a 42mm one, and I'm going to run the application. And then we are going to wait for a few seconds. And there it is. There is our interface controller. And once I click Save Location, you see we're being pushed to the next interface controller. It's that easy. And we can even go back. So now that you've seen how you can test the application, what we need to do is creating a new class which we can use to implement some logic for this interface controller, which includes the map. And as you can see, we don't only have a WristyLocation WatchKit app folder, we also have a WatchKit extension folder. And this is actually where all the action happens. So we will add a new class. It's a Coco Touch class, and we will call it, let's say, your location. And this is going to be an interface, WatchKit interface controller. We hit next, and we add it only to our WristyLocation WatchKit extension. We don't need to add it to any other targets, so let's create it. And there we go. And then exactly as we do it with standard iOS apps, we can now click on the interface controller, bring up the identity inspector, and add the Your Location interface controller. And as you can see now, once I activate the assistant editor, we can simply create outlets for our interface controller. And the only thing we want to add here as an outlet is the map itself. And again, the same thing applies here, that we need to import CoreLocation. This is the same thing we needed to do in our iOS app. And we can also create an action for our Done button, which will be pretty simple. But nonetheless, let's call it Dismiss Interface Controller. And this was not an action. This was an outlet. So let's do it again. Dismiss Interface Controller. This time, let's definitely select the action, hit connect. And all you need to do to dismiss an interface controller is, as long as it is pushed, we simply pop the controller, just as we would do with the navigation controller. But before we continue adding the logic for adding a location from our Apple Watch, let's also add another button here to our first interface controller that will allow us to display the locations that we've already saved on the iPhone. So I've just added another button. Let's call it all locations, and let's also create another interface controller here. Let's bring that one to the bottom, let's bring that one to here, and we will again add a push segue between those two controllers. And the most efficient way to display that kind of data would be to use something like a table view controller or a table view. And indeed, the WatchKit supplies us with a table that works very like a table view controller, but is a little different after all. So how do we configure this? We should first of all have a look at this placeholder here, and if we have a look at the document outliner here, then we have an interface controller which contains a table, which again contains a table row controller, and this table row controller again contains a group. And this is so we could call it our prototype cell. So that means that we could bring up a label and put it right in there, and then again we can position it using the attributes inspector and center it vertically so that it looks quite nice. And we will also, just like using a table view controller or a standard view controller, we also will need to create another class in our WatchKit extension here, and we'll simply call that locations interface controller. And we will also add that to the WristyLocation WatchKit extension. And now that we have created this interface controller, we can, again, just like with using interface view controllers, have to order this a little more. We can now select this interface controller, which we have just created, and then add this as a custom class and just call it locations interface controller. And it is now a little different to configure these this table row controller. To create now to use it to display our data, what we need to do is to create another class which is going to be a subclass of NSObject, which will then call, for example, a location row controller. And we'll save that also to our WatchKit extension. And when we go back to our storyboard in the WatchKit app, what we need to do now is select the table row controller in our document outliner and select the location row controller as a custom class, and also give this an identifier, which is going to be called location row, for example. All right, now that we have created all of these classes, we can continue to work on our locations interface controller. First of all, for that to work, we need to import our watch proxy to get all the necessary classes. What we'll also need to do, since we want to get our data using CoreData, we need to import CoreData. All right. Now we will need some properties, which is first of all a managed object context, as you already know, which is going to be NS managed object context. And what we will also need is again a location array, which will then contain an array of location objects. And as you can see, we cannot really use the location class, and this is because we haven't imported it yet to this target. So what we now need to do is create another bridging header within our WatchKit extension, and to do that we create a new CocoaTouch class, but this time using Swift as a language. We can call that whatever we want, as you can see here, and we'll simply create it. And now Xcode is going to ask us again if we want to create a bridging header. We want that, and then we can again get rid of these two class files that we have created and move them to the trash. And now we can again import the location.h file to our WatchKit extension. And once we go back to the location interface controller, you can see that we can actually use this class. Now that we have these two properties in place, we can also create an outlet for our row controller. So we select our table and open the assistant editor and control drag to the assistant editor and call this, for example, location table. All right, now let's go back to the location interface controller and do the actual fun stuff. And now you're going to learn how to actually use these row controllers. And actually the same thing as view.load for our view controllers. This is going to be awake with context is the way you do it with the WatchKit SDK. So we want to initialize our managed object context, so we can use our Swift CoreData helper and get our managed object context, and we can then use our location array and fill it with all the entities that are available to fetch from our database. So the class is a string from class location again. We won't need a predicate, we won't need a sort descriptor, and the managed object context we want to work with is of course MOC. And after we have casted, well, actually we don't need to cast, we need to cast it to a location array. And after we did that, we can now set the number of rows for our table, for our interface table. So let's use the location table and set the number of rows to our location array and the count of it with the row type. And now we will state the row type that we have defined, which was location row. This was actually what we have defined in the storyboard once we clicked on the location row. And in the attributes inspector, you can see that we have used the identifier location row. So if we now, I paste that again here to make no spelling mistake. Now that we have the number of rows available for us, we can now iterate through our nodes table using a for loop. So let's say for a counter variable I, which is going to be 0, and cast that as an integer. I is less than the location table dot number of rows, for example, I++. Let's increment that. And now we can create, let's say, the row, and we can then say location table row controller at index I as location row controller. Don't forget the exclamation mark here. And now we have a row, and now we also need the location. So let's say location, and this is going to be the location array, and we access it with the counter variable. And now we can say the row dot title equals our oh no, we have to use the set text property. So let's just go back for a second and let's add the necessary outlets to our row controller. So we will use the assistant editor, open the location row controller here at the top if it's not automatically selected, and then we will simply drag to the row controller and call this label title label, for example. And as you can see, because we have created an NS object which has nothing to do with WatchKit, actually, we can't use the WK interface label. So we have to replace the import statement here of UIKit with WatchKit and build that again, and that succeeded. So after we have changed that from WatchKit, from UIKit to WatchKit, we can go back to our location interface controller and use now our row and its its title, we call it title label, and set the text to the location and its title, since this is an attribute provided by our data model. And well, actually that's it. We can and should give it a try. So let's run our application first of all on the iPhone simulator to create a nice location. So here we are in Manhattan again. Click the plus icon and we are at, let's say, Times Square. Let's say at Starbucks, whatever. add that, and we are here, and once we click on that, you can see that we are here at the Times Square. There must be a Starbucks somewhere, of course. And now we have created our first entry. You can see when we click on that, we go zoom back out, so that works quite nicely. And now I will terminate the app and then reopen only the WatchKit extension. And now I will press all locations, and there we are, Starbucks. And that means that we now have a working connection between our iOS application and the WatchKit extension, and this is pretty nice. So now that we have the fruits of our work at hand, let's also go ahead and think about the map and how to save the location on the iPhone. And this is some pretty hard work that should be done partly on the iPhone, since the calculation power of the Apple Watch is limited. So let me show you how we're going to do this. So let's head back to our Your Location interface controller, where we already have made the basic setup. We have imported CoreLocation. We have also created an outlet of our map. Now we're going to need to get our location, and therefore we will again use the CL Location Manager delegate. We will again create a location manager and use CL Location Manager, and we will then create another delegate method of the WK interface controller, which is going to be the init. So override init, and we will call first of all super init, and then afterwards we will use our location manager and initialize it while using CL Location Manager initializer, and then we will again set the delegate to self, and also we will start updating locations. All right, and now that we have the location manager delegate, we can, as we did it with the iOS application, we can use the different delegate methods. So let's first of all use, in this case, the location manager did fail with arrow, so that we can, in the case of an error, we can just print line it and get to know more about this error. And of course, we'll also use the location manager did update locations method. So did update locations. And what we now need to do is first of all tell our location manager, which could be also, we could also use this parameter here, to stop updating locations. So this is the first thing here. Then we could print line, for example, our location that we are our locations array that we get from the delegate method, and then all we need to do is get the first location from this locations list. So let's say locations.first and cast that to a CL location object, and then we will call our map just using map.remove all annotations so that we have a fresh and new map. And now we will add again an annotation to our map, but not with an image. We will use a pin, and in this case we again use our location that we've just received and its coordinates with a pin color of red. All right, and now we need to set the region of the map. So let's define a region using mk coordinate region make with coordinates again. So again, our location object is needed and its coordinates and the span. We'll just do it like on the iPhone by using mk coordinate span make, but this time with a latitude and longitude delta of 0.01. Again, 0.01. And that's it. And now we can actually set the region for our map, just calling set region region as a parameter, and that should do it. And now we actually come again to a very interesting point in our WatchKit application and how it deals with transferring information from the Apple Watch to the iPhone. What we are going to do is we will use a method called OpenParentApplication. That is a method of the WK interface controller, and then transfer all the necessary data to our iPhone application. But what actually are we going to transfer? Well, it is going to be a location object. So let's create a location data object, and again use the NSKeyed archiver and archive data with root object, which is again going to be our location. And then we want to check if our data transfer works. So let's call WK interface controller dot open parent application. Well, and now this is really interesting. The user info object that we will now, which is a dictionary, which we will now transfer to the parent application, will not actually open the parent application on the iPhone. It will simply send the information, and the iPhone has to process that in the background. So everything we put into this dictionary will be transferred to the iPhone and should be somehow archived like this in an NSData object in order for you to use it properly. And then again we get a reply with and we could use this reply to work with on the Apple Watch again, but we won't do that in this example. So we will now actually define our dictionary with the key location, and then add the location data as a value. And as you can see here, for the reply, which we will get from the iPhone again, we have two parameters. The first one is a dictionary as well, which contains the actual reply we get, and an NSError object, which we can use to process any kind of errors that occurred in the process of replying from the iPhone, or talking from the iPhone back to the Apple Watch. So if this worked, we can actually print line data transfer successful, else we say something went wrong. All right, let's build that. Build succeeded. All right. Now we have called the open parent application method here, but where is it actually called on the iPhone? Well, therefore, we are going to use app delegate. And there is now a pretty handy method that we can use to handle these calls from the Apple Watch. So let's scroll down a little and let's add the application handle WatchKit extension request method. And this is pretty cool now. So we have our user info object that we have received here, and we're going to use it now. Okay, so let's create an info dictionary by accessing the user info dictionary and access its location key. And now we have to specify what kind of dictionary this should become. So let's say dictionary, and explicitly tell it that the key is going to be a string, and the value is going to be any object. And now we can work with that info dictionary. Let's see what's wrong here. Let's not access this at this time. Let's simply cast it here, and now let's check if there is a location available for us. So let's use the info, and then we will use the location key that we have specified, and then we can cast that to an NS data. And now we can create a managed object context using Swift CoreData helper managed object context to use it again to now save the location that we have received from the Apple Watch to our database. So let's create a location object, which is going to be the location object here, but unarchived. So let's use ns-keyed unarchiver, and then let's say unarchive with ns data, and this is going to be our location object, and we can simply cast that to a CL location. But to do that, we again have to import core location here at the top of our app delegate. All right, now that we have that, you could argue that we could simply save the location object to the database, but what we need to do, since we did not allow the user to dictate anything with the Apple Watch, we need to get the address, and therefore we will use a geocoder using CL geocoder, the CL geocoder class, and we will then say geocoder reverse geocode location, and therefore we are now using our location object, and in the completion handler, which gives us two parameters, an array of ns object of any object, which is actually the result of our query here, and an error, which is an ns error. All right, and if there was no error, so if the error gives us is equal to nil, we can create an address object by using the result and its first object and cast that to a CL place mark. And then we can actually create a formatted address by creating a string beginning with the address and its name, and let's say a comma, and then again the address and its postal code, and then again maybe we don't need a comma here. All right, so and here the address and its locality, and that's it. So now we can create a, let's call it database location object, and use again our Swift CoreData helper and insert a managed object of a class, of a specific class. So NSString from class, which is location, class location, in our managed object context MOC. And now that we have this database location object, we can use its title and set this to the formatted address. And we can also set the coordinates, so database location object coordinates. This is actually our location that we have received as an NSData object from our Apple Watch already. So here I forgot to cast that to a location object, and that actually should do it. All right. So now all we need to do is actually save our managed object context. So let's say Swift CoreData helper, save managed object context. And well, now we will need to supply it with the MOC. And then, which is really cool if you have your Apple Watch running and you save the location, in order for the iPhone to respond directly when the our WristyLocation is open on the iPhone, we will send a notification. So let's say NS notification center, default center, post notification, and we'll call it database update received, and don't transfer any object here. And then we can go back to our view controller on the iPhone app and go to the view.load, and within view.load, before we set up our table view, we can add the NS notification center, default center, and then add an observer for self for the selector database update. That's not a selector. The selector is going to be load data because we want to call the load data method. The name of the notification, of course, is database update received. I'm going to copy that again, and the object is nil. So let me just copy that and paste it here in app delegate so that we don't have any spelling mistakes. And I just thought about one thing and did select row at index path, because here when we did select the row at index path, we should also call the location manager to stop updating location, because that doesn't make sense here. So location manager stop updating location. All right, and now give me just a second to bring up QuickTime again so that we can test whether our nice little application works. So here we are again, and here is the live video from my iPhone, and here is now the video from the Apple Watch. And if I now press save location, you can see that immediately well, it was immediately the address appears on our table view controller and also on the Apple Watch. And when I click or press done on the Apple Watch and press all locations, you can see that we get the same location that we have on the iPhone also on the Apple Watch. And if I go back again and click plus here and enter Starbucks, for example, again, Starbucks, and add that to my location here. So here somewhere is Starbucks. All right, and I go back. So I just have to enter my PIN code again. So if I go back to the Apple Watch and press all locations, then you can see we have both locations that we have stored in the database also on the Apple Watch. So this was a huge tutorial about, and also an introduction to working with the Apple Watch SDK, and also how to integrate core data databases and how you can actually connect core data using app groups so that you can talk from your iPhone application to your WatchKit application. You have seen how to send requests to the iPhone and how to process them on the iPhone. I hope this was a fun tutorial for you as much as it was for me. Let me know what you think, and if you have questions or anything, feel free to comment below, and don't forget to have a look at PRENTIS and also tell me what you think about this new way of finding people and share talents with each other. So have fun and have a great week.